so oftentimes it is useful to change two or more fractions into their equivalent fractions. So that they will have the same denominator. So we already saw that when comparing fractions. There are times that we're going to make them have the same denominator so that we can just compare the numerators. There'll be other opportunities for needing this skill as well. Now there's something called the least common denominator, and you saw that in your journal. That you're going to try to use, but if you don't, as long as you're careful with whatever denominator you do use. So the least common denominator, which is abbreviated LCD because it's just too long to even fit on that line, of two or more fractions, is the number that is the LCM of the fractions denominators. Partly why we did the number theory review before getting into this fractions unit. So if you rewrite the fractions using the least common denominator, you'll be able to do calculations with smaller numbers than if you use like the quick common denominator, for example. And you might save yourself work when putting your final answer in simplest form, if it's an addition or subtraction problem. So down here we have an example where we might need to compare, add, or subtract 5/12 and 3/8. So does everyone have the blanks filled in so far? So if we needed to compare, add, or subtract 5/12 and 3/8, we could change both fractions to have equivalent fractions with a denominator equivalent to 12 times 8, but the calculations might end up being difficult. 12 times 8 on its own, a lot of people mess that up and say 94 or 98. But also you would end up with 40 as your numerator for what used to be 5/12, and you would end up with 36 for what used to be 3/8, and then you'd have to work with those numbers. So instead, find the least common multiple of 12 and 8 first, and use that as the denominator. Since the least common multiple of 12 and 8 is 24, you can change 5/12 by multiplying the numerator and the denominator by 2 into 10/24, and you can change 3/8 by multiplying the numerator and denominator by 3 into 9/24. And that way you can compare them, or you can add them, or you can subtract without having to worry about the numbers being a bit larger and without having to worry about simplifying what the sum or the difference would be. So today we're going to focus on adding and subtracting fractions. If I had 1/4 plus 5/6, I cannot add fourths and sixths. Think about my cheesecake again. They're different sized pieces, so I can't say, oh, I got 1 of those and 5 of those, therefore altogether I got 6 of what? They're different sized pieces. I can't add them yet. So instead we're going to make them have the same denominator, so that I'm dealing with the same size pieces. I get this amount of this size pieces and this different amount of these same size pieces, then I can combine them. Now, your book had something called the quick common denominator. So if we were doing something of this sort with the quick common denominator, we would use 24ths. So 1/4 plus 5/6, I have to rewrite it. I can't just clobber over my original problem. I have to rewrite it with common denominators. And again, I forget sometimes the decisions I make. So I would write, I've got 24ths plus some other amount of 24ths. So 1/4 is equivalent to how many 24ths? You, sir? 6 24ths. And 5/6 is equivalent to how many 24ths? Yes, ma'am?
20.
20. So now I have same size pieces. Now I can add them up. And when I add them up, I get 26 24ths. So that's not proper, because that's an improper fraction, and it's not simplified. So I have 2 steps to show how to get to a final answer. Whenever you're doing work in math, on math assessments and such, you want to say, okay, I want to make sure it's clear how I get from the original problem all the way to the answer. So we have two options. We could simplify it first. We get 3/12. Or we can make it proper first. You wouldn't do both. You would do one or the other. That's supposed to say or. If I made it proper first, I'd do 1 and 2/24. See, neither of these is a final answer, but it's a step towards getting a final answer. Who can tell me what the final answer would be for adding up these two simple fractions? Yes?
1 and 1/12.
1 and 1/12. So by using the quick common denominator, I had slightly bigger numbers. They weren't terrible, but then I had to show 2 steps to get to a final answer at the end. Who can tell me what the least common multiple of 4 and 6 are? 12. If I use 12 instead, I use the least common denominator, I'm going to use 12. Some amount of 12s plus some other amount of 12s. 1/4 is equivalent to how many 12s? I multiplied 4 by what?
3.
So I need to multiply 1 by
3.
to get
12.
1 times 3?
3.
3.
12.
3/12. 5/6 is equivalent to how many 12s?
10.
10 12s. I add up 3 12s plus 10 12s and I get
Oh,
13 12s. So I do still have to make it proper in the end. But it saves me a step of having to go, ooh, I got 2 steps to show. So making it proper in the end, I get 1 and 1/12. Check out this subtraction problem I put on here next. If I use the quick common denominator, I have 2 fractions to change, and I have more simplifying to do. So quick common denominator of 3/3 and 9ths would be 27ths. I had to multiply the denominator by 9, so therefore I have to multiply the numerator by 9 to make it equivalent. 18/27. And then 2/9 is equivalent to how many 27ths?
6.
6/27. So I converted both of these fractions to equivalent fractions in order to use this quick common denominator. If I have 18/27ths and I take away 6/27ths, what's 18/27ths minus the 6/27ths? 12/27ths. A lot of people would think, whew, that was a lot of work, I'm glad I'm done. Not done. That's why we did divisibility rules. Because sometimes using divisibility rules you can say, oh wait, yep, they have a factor I could divide out of each. What's a common factor of 12 and of 27 that I could divide out? 3. So divide a 3 out of the 12, divide a 3 out of the 27. What's the simplified fraction we're going to get?
4/9.
4/9.
Also in the second.
And then I think, okay, 4, that's 2 times 2, and 9 is 3 times 3, so now it's simplified. Let's look at what happens if I use least common denominator. What's the least common multiple of 3 and of 9? What's the first thing that 3 can skip count by that 9 can also skip count by? 9. I can actually use 9ths. This makes it so I don't even need to change my second fraction. It was 2/9, it's going to stay 2/9. My first fraction, however, is going to change. 2/3 is equivalent to how many 9ths? 6/9. I multiplied by 3, so I multiply numerator by 3. So now I have 6/9 minus 2/9 is what? If I have 6/9 minus 2/9, that equals what? 4/9. We're already done. We took this problem from something where we had to do 1, 2, 3, 4 things to a problem where we just had to do 1, 2 things by using least common denominator. Yeah, it would be there. So if possible, try to use least common denominator, but it's not required.